without any third party to transfer that asset to any other third party in the world, just by snapping your fingers. So we started out with algorithmic tokens. When you look at things like Bitcoin and Litecoin and Ethereum, built into the code tells you how many tokens there are going to be. So there are around 17 million Bitcoins in circulation today, and we know for a fact that it will never exceed 21 million Bitcoins. Now this is an algorithmic issuance. The same is true for Litecoin, the same is true for Ethereum. These things can be proven in the code and guaranteed for everyone to look at. So there are actually 5 attributes that all digital assets contain within themselves. And this is what we've learned over the course of the past several years. We start with it being finite. This is the digital scarcity aspect. You know for a fact how many there are going to be. They're all authentic. They cannot be counterfeited, they cannot be duplicated. Every Bitcoin can be traced back to its origination point. All of these assets are transferable. Peer-to-peer. I can send them to you, you can send them to me, we can send them to anyone in the world without having to ask permission for anything. They're possessible. Once you have the key, those assets are exclusively yours, and you have complete control over the disposal and use of those assets. And again, they are traceable. On a public network, you can see every single transaction as it goes across the network. You can trace back every transaction you've done to the point where you receive the coins. So therefore, everyone can validate and verify all of these attributes about the tokens. So what you're looking at here is a terrarium. This is a natural system that is completely self-contained. In this instance, you've got bacteria, you've got a little lizard, you've got plants, you've got carbon dioxide, you've got oxygen, but it's all contained in a single entity that's completely sealed. Well, it's a balanced network. In a sense, it is decentralized. It has delegation. There are certain elements that you want to do. The bacteria are the ones that process the oxygen, and they spit out carbon dioxide. The plants take the carbon dioxide and convert it with light into oxygen for the lizard to be able to breathe. These things have checks and balances. They are also autonomous. They need no outside influence whatsoever. And within their contained system, they are self-sufficient. So using this terrarium as a model, I like to propose the concept that a blockchain itself is in fact a living thing. It's the first example of technological life that we've ever worked with. Now, it's not artificial intelligence, because they're not very smart, but they're completely self-standing, self-sufficient. There is no server anywhere that runs a blockchain. It's simply a series of messages that we all pass around to one another. And it looks like a living network, like a living thing. As Andrew was just showing us, we've got networks and interconnections between ourselves. Well, a blockchain does the very, very same thing. So like I said, we started with algorithmic tokens, where you knew for a fact in the code how many tokens there would be and how many tokens there would ever be. The next progression that we had was this concept of managed tokens. And we started with Tether. Now, Tether is a company that actually digitizes dollars. We have a reserve across a series of banks where we're holding around $1.6 billion worth of dollars. And we've issued tokens against those dollars and given them to the customers and the users of the Tether platform. Well, now we've actually used this aspect of digital scarcity to map one-to-one assets in the real world to assets on a blockchain. Now, these managed tokens can be pretty much anything. They can be equities, they can be securities, they can be property, they can be real estate, they can be other things as well. Because all of these assets I've described thus far are all what we call fungible. They're all interchangeable with one another. They're all, in essence, the same thing. One Bitcoin is the same as any other Bitcoin. One Tether is worth $1 and worth every other Tether. So they're all the same thing. So the question is, what happens when we add more attributes? On this chart, you can see we've got 5 things where all digital assets contain these attributes. Before we get there, though, here's the quick progression that we did. In Bitcoin, we had mining and proof of work. These are the things that actually assured the network that the transactions were solid and safe. And they have algorithmic issuance and explicit transactions. When I want to send someone a Bitcoin, I've got to tell the network, I'm sending a Bitcoin. Now, we built a platform called the Omni Layer on top of the Bitcoin network, and it added some additional capabilities. It allowed for managed issuance of assets. It's an on-chain meta protocol, and it allowed for implicit transactions that says, I'm going to offer this up for sale. If you send me tokens, you will immediately receive the other tokens in exchange. So we now have implicit transactions, so automation on a blockchain. And so with Tether, we made a reserve-backed asset. Okay, it represents currency, and it allowed for redemption of that asset. If you want that dollar back, you send your Tether to Tether, and it gets destroyed, and your dollar gets sent back to you. Well, with an organization we've been working with called BlockV, that's taken this concept one step further. And we've gone from what we call digital assets into digital objects. These things that can be managed in their scarcity, and they can have localized rule sets. You can actually tell them what to do. And it allows these objects to actually interact with one another on a blockchain. So besides the first 5 attributes, we've now added programmability to digital assets. Now, I'm not talking about smart contracts. If you think about smart contracts, they're in essence an arcade machine that says, I will take a token and process that token for you. And while that's extraordinarily innovative, we wanted to see what would happen if you make the asset itself programmable. Now, you guys may have seen CryptoKitties over the past several months clogging the Ethereum network. This is the very, very beginning concept of a programmable digital object. These things can have individual code, and you can tell them what to do. And so eventually you're playing with video game objects that are in fact blockchain assets, where each one is in fact unique. And it gets very, very interesting at this point, because these assets, these objects, can actually be combined with one another. Now, instead of just a balance in a wallet, where you have X number of Bitcoins or X number of Ethereum, imagine that you're working with a 3-dimensional unique object that you're picking up with GPS coordinates as you walk down through the mall. Well, if you pick up enough of these pieces, and they happen to be puzzle pieces, what happens when you combine those things? Well, they become something else. They become a new kind of asset, a new kind of object. In this instance, they become frozen yogurt. And now that frozen yogurt is redeemable. So you start seeing the possibilities that we have with digital objects, digital assets, when you start programming them into things that are themselves unique. As an example, Tethers are redeemable for $1. And that's very, very simple. But why not make the asset, in fact, interactive? How about if I share that asset with my friends? A sponsor like Coca-Cola could create a digital object that gives me a free Coke every time I share a certain number of assets with my friends, which builds a social graph, it builds a social network of people who are interested in that product. What if the assets themselves are network aware? They can look off the blockchain. This is an example of a collectible trading card for Jeff Gordon, a NASCAR driver, where if you hold the asset while he won a race, now your asset is worth more than the next guy who picked it up. You have a commemorative asset because it was aware of activities that occurred through Twitter feeds or RSS off the network, off the blockchain. And then you can begin to add in artificial intelligence, because these objects themselves can become autonomous. They can then interact with one another without human interaction whatsoever. Andrew was showing us what social graphs look like and what these smart robots and devices can do once they have a little bit of intelligence and the ability to interact. Well, now you've got the platform on top of a blockchain to give them this. So we have a trillion object opportunity. If you think about the apps in your pocket, there are millions of apps out there, and they are in fact programmable digital objects, but you don't actually own them. I can't send an app on my phone to a friend of mine, but I can send a digital object on a blockchain to a friend of mine. So this is the concept of a digital object. The question is, who are you? How do you guys interact with these things? Well, not to give you a surprise, but you are in fact a digital object. Go to your bank, you're an entry in their database. Go to a hospital, you're an entry in their database. The Social Security Administration has you as an entry in their database. Interesting thing about decentralized identity is that it is separate from this concept. The government says who I am, Facebook says who I am, Google says who I am, my insurance company says who I am, but I need to say who I am. So we've actually boiled down 3 attributes of a decentralized identity, the things that comprise who you are and what you are. And it starts with a simple declaration: I am. I am correct. I own my identity, and I have rights with that identity. Very similar to that key that I hold on the blockchain that holds my assets, a very similar kind of key can hold my identity and who I am. I then have the ability to affirm, make affirmations about myself. I have brown hair. Well, a bank is also an identity. In fact, they can claim that I'm an accredited investor. And we can build a social graph and a social network of ourselves about reputation and identity. We can also grant aspects of ourselves. We can give our insurance company the right to our health records, or we can allow our mother to pay our phone bill. So once you actually have self-sovereign control with cryptography on a blockchain, not only do you have this possibility of programmable digital objects, but you have the opportunity to identify yourself and take ownership of yourself and your identity. At the center of all of these things is you. And as you make activities on a blockchain, as you send things around, you have your assets. These are the things that you own, the product of your labor, that you control through your identity. You've got social media. You've got all of your friends as you interact with them as well. And then of course you've got the full community at large, which you can enable with these networks. So I'll tell you this, the future is actually a story waiting to be written. It's at the intersection of experiential technology, which you've just seen, and all of our collective imaginations. So I look forward to the things that you guys create on blockchains as this revolution continues. So if you want information about digital objects, please go to blockv.io, and I look forward to talking to you guys soon. Thank you very much, everyone.